Now if we have, like we had for forces, the force on it on the particle number 3 was F13 plus F23. Similarly, the electric field at any point is the electric field due to the charge 1 plus electric field due to charge 2 plus any other charges. So if I have Q1 and I have Q2 and I want to find the electric field here, if these are both positive, well, the electric field will be in this direction, and due to this charge it's going to be in this direction, and the resultant electric field is going to be the sum of these two. So I can add these two vectorially, and that will be the resultant electric field. And if there's more, we just do the same thing. So now we take another example, and in this case we have three charges, Q1, Q2 and Q3. Q1 and Q3 are positive, Q2 is negative, and the values are 4, 3 and 5 microcoulombs. And this distance is A, which is 0.2, this is 0.3 meter, and it's a right triangle. We want to find the force on charge Q3 due to these two charges, and that's going to be the sum of the two forces. So we'll have a F13 force on 3 due to 1 pushing this way, and F23 force on 3 pulled this way due to 2. And then we'll find these as vectors, and then we'll add the two together to get F3. So F13, this one, is going to be KQ1 Q3 over R13, which is the same as C, and the unit vector R13, which is going to point this way. So we have the value of K, the value of Q1 and Q3, both are positive, and this is the value of C is A squared plus B squared, and we'll take the square root, so using Pythagoras theorem, because this is a right triangle. So C squared is going to be 0.13. We just put it over here because we need the square. We'll leave the unit vector for a minute, and then we solve this part, which comes out to this many newtons. So that is the magnitude of the force F13. Now the direction vector is cosine theta I and sine theta j, where theta is this angle. Now we get theta from these two, so theta is going to be tangent inverse A over B, and we plug in the numbers and we get 33.69 degrees. So this is 33.69 degrees, and then we get the cosine of 33.69 and the sine of 33.69 multiplied with this. These are the values, and multiplying them we get out our value of F13. Now F23, which is this force, is going to be K, Q2, Q3, and the unit vector R13. Sorry, 23. So the K is here, Q2 and Q3. Now Q2 is negative, R13 is plus I because it's pointed to the right, and then the distance is 0.3. We solve that, we get 1.498 in the negative I direction because of this one, and we get a Newton. And now we add these two and this. So we write the first vector and then the second vector. We add the two I components together to get this and the j component. So that is our final answer. F3 vector. Now if we want the magnitude, we can take the square of each and square root, because it's these are rectangular to each other, and this comes out to 0.842 newtons, and the angle will be tangent inverse of the y component over the x component, which comes out to 114 degrees. So it's going to be, this angle is 114, this angle is 65, and so with this angle at 114 degrees we have a force pointing this way, and that becomes the resultant force F3. Okay, so So you can write it like as a vector like this, or in terms of a magnitude and a direction. Okay, so these are the final results.